previous topic, we have studied about the atomic mass, gram atomic mass, molecular mass, calculation of molecular mass, and so on. Now we are going to measure the amount of matter, substance, particles, whether it is atom, molecules, ions, or any other particle. Now we see here that is in a chemical reaction the atoms or number of molecules are represented. For example, suppose in a chemical reaction we take this example, Na plus H2O gives NaOH plus H2. So in this part you see that in a reaction we take mass of the substance in proportion or the number of atoms or molecules. Like 2 atom of sodium combines with 2 molecule of water to give 2 molecule of sodium hydroxide and 1 molecule of hydrogen. Or we can represent it by taking their masses. So it is quite convenient to express or measure the amount of substance in number of particles contained in it. It was used a term mole. That was, a mole was introduced as a unit. Now it was introduced by given by Wilhelm Oswald. It was introduced by Wilhelm Oswald in 1861, but it was accepted in our common form of unit in 1967 by our modern scientists. Now then, what is mole? So just we have discussed that is mole is the amount of substance such that it contains a certain collection of number of particles. So we say that what is a mole? Then we define a mole of any species species means entities, particles, species that may be atom, molecules, ions, or particles. Means it may be atom, 1 mole of atom, 1 mole of molecule, 1 mole of ions, and so on. In number equal to the atomic mass or molecular mass in gram. Now we see, we can define it like this. A mole of any species is in number, a mole of any species in number equal to the atomic mass or a mole of any species in number is equal to the atomic mass or molecular mass in gram. It means that we can say now that if we take atomic mass in gram, it will be equal to 1 mole. Similarly, if we take molecular mass in gram, it will be again equal to 1 mole of that substance. Now, then since the meaning of mole is heap or big collection. So this is a big collection of number of particles. Then what is the number of particles contained in 1 mole? Now we see that 1 mole is equals to 6.022 into 10 to the power 23 particles. So 1 mole of any substance will have this much number of particles. this number is known as this number is known as Avogadro's constant, Avogadro's constant or Avogadro's number, Avogadro's number, which is represented as this one, n capital N small o. This is to represent the atomic, this is the number used to represent 1 mole of particles or 1 mole of any substance. Now, it was Amadeo Avogadro who introduced this number. Now we see that when we have to take 1 mole, then we write here that suppose we write relationship with atomic masses or molecular masses. Suppose we write 1 mole of atom. It means that it is equals to gram atomic mass of element, and in number it will have 6.022 into 10 to the power 23 atoms of that element. Means we can say that 1 mole has this much number of atoms. 1 mole of atom will have its mass equals to gram atomic mass. So, in relationship we say that in gram atomic mass of any element, the number of atoms will be this one. We can also say the mass of such number of atoms is equals to its gram atomic mass. Now, suppose we can take some more example, but again write for the molecule also. Suppose next 1 mole of molecule. Now, the molecule may be that of element or of a compound. 1 mole of molecule is equals to gram molecular mass. Gram molecular mass of substance. Substance means it may be element or compound. Or we can say directly, that is the molecular mass in gram is equals to 1 mole. Now, it will have number of particles, number of molecules equals to 6.022 into 10 to the power 23 molecules of that substance. So, this is the basic concept of mole. Now, here again you have to remember that the relative atomic mass, or we can say the atomic mass in AMU gives the mass of 1 atom of the element. But the gram atomic mass or atomic mass in gram gives the mass of 1 mole of the atom, that is atoms of this much number of atom. So these were the 2 points related to the relation of mole concept. Now we can further write here. Again, you have to learn this point that the atomic mass in AMU or U gives the mass of 1 atom of element. 1 atom of element. But at the same time, atomic mass in gram gives mass of 6.022 into 10 to the power 23 atoms of element, which is also equals to 1 mole of element. So this is the basic difference. If the mass is given in AMU, it is for 1 atom of element. And if the mass is given in gram, atomic mass is given in gram, it will be equal to 1 mole of the element. That is collection of this much number of particles. Now, similar concept can be taken for the molecules also. The molecular mass of substance in AMU will give you mass of 1 molecule, but the molecular mass in gram will give you the mass of 1 mole of the substance, that is this much number of molecules. So this can be made more clear with the following examples. Like suppose here question number 1, find, or we can take first of all example, then we'll come to question. Example, if we have 4 AMU of helium, as we know the relative atomic mass of helium is 4 AMU. So if the mass is given in AMU, then it is 1 atom of helium. 1 atom of helium. But if we write 4 gram of helium, then it is equals to atomic mass in gram. So it is equals to 1 mole of helium. That is 6.02322 into 10 to the power 23 atoms of helium. That is 1 mole of helium. 1 mole of helium. So this is the basic difference. Now we can take an example, question number 1. Find first number of moles in 52 gram of helium. Next, number of atoms in 52 gram of helium. Next, number of atoms in 52 AMU of helium. Now, first of all, come to this part. The number of moles in 52 gram of helium. Now, this is given in gram. So, we will compare it with gram atomic mass. Now, we know that 4 gram helium equals to 1 mole. Gram atomic mass of helium is 4. So, 4 gram helium equals to 1 mole. So, number of moles is equals to given mass in gram by gram atomic mass. That is, now it is 52 divided by 4, hence 13. So there are 13 moles. We can also find it out in unitary method, like since 4 gram helium is 1 mole, then 1 gram helium 1 by 4 mole, then 52 gram helium 1 by 4 into 52, that is 13 mole. So if the mass is in gram, we will compare it with the gram atomic mass. Now the second part, number of atoms. Now we can compare it in 2 ways. One, gram atomic mass of substance is equals to this much number of atoms. So we can find it out in 52 gram, first thing. Second, since we have calculated the number of moles, and as we know 1 mole is equals to 6.022 into 10 power 23 atoms. So that number means Avogadro number will be multiplied by by 4. So for the next part or second part we see, that is second part, we can find it out in two ways. First, since 4 gram helium is equals to 6.022 into 10 to the power 23 atoms. Therefore, 1 gram helium 6.022 into 10 to the power 23 by 4, and hence 52 gram helium will be 6.022 into 10 to the power 23 by 4 into 52. Now this is 13, hence you can multiply here 13 to the 26, 2 13 to the 26 and 2 28, and then 13 6 is 78 into 10 to the power 23. Hence this is the as a whole taken. Now it will be, if decimal is shifted to first digit, 7.8286, or it can be rounded off as 7.83 into 10 to the power 24 atoms. So this is the answer. Or there may be another method, comparing it with number of moles. Means first of all you will find the number of moles and then multiply it with Avogadro number. Like you can find number of mole. Just we have solved the first example, first part, 52, that is the given mass by gram atomic mass, hence it is 13. There are 13 moles, and as you know that 1 mole is equals to 6.022 into 10 to the power 23 atoms. Hence 13 mole is equals to 13 into 6.022 into 10 to the power 23, that is 7.83, rounding off 83 into 10 to the power 24 atoms. So you can find it out indirectly, that is by using unitary method or by using this method. So you have compared the mole, the mass and the number of atoms. In the third part of the question, now you see, in the third part of the question you see that we had 52 AMU of helium. Now it is given in atomic mass unit. So we will compare it with relative atomic mass. Now as you know that since 4 AMU, which is the relative atomic mass of helium, 4 AMU is equals to 1 atom of helium. 4 AMU of helium equals to 1 atom. Therefore 1 AMU 1 by 4 and 52 AMU, just you see here, that is 1 by 4 into 52, hence just 13 atoms. So in part B and part C you can easily make a difference. In part B the mass was given in gram, so we compared it with mole or Avogadro's number. But in part C the mass is given in AMU, so it is compared with relative atomic mass. Now this was the first example. Take more example. Now you see, student, sometimes the number of atoms are required to be obtained in a molecule. In that case, if the molecule of compound or element is given, then first of all find the number of molecules and then go for the number of atoms. Then how can you calculate it? Then first of all find the number of molecules comparing with gram molecular mass. And then see that what is the number of atom of a particular element in one molecule of that substance. Like you see, first of all, suppose we take question, find number of mole in 8.5 gram ammonia. Second, number of molecules in 8.5 gram ammonia. Third, number of atoms of, suppose only hydrogen, we take hydrogen only, hydrogen in 8.5 gram ammonia. Now again you see here, student, this is the mass and this is the molecule. So this time you will compare it with gram molecular mass, not with the gram atomic mass. Means if we will solve it, since this is the molecule and mass is given, so we will use gram molecular mass. So first of all we write gram molecular mass of ammonia. Now we have used molecular mass. Now you will add the atomic masses of these elements. So its atomic mass is 14. Here it is 1 into 3, that is 17 gram. Since we have used gram molecular mass, so we use it in gram. If you will take relative molecular mass, it will be in AMU. Now just come to here. Since this much number, since 17 gram of ammonia is equals to 1 mole, therefore 1 gram ammonia 1 by 17 and 8.5 gram will be 1 by 17 into 8.5, hence 0.5 mole or 1 by 2 mole. We can also take it directly. We have used unitary method here. We can use it directly also, that number of mole is equals to given mass by gram molecular mass. So we can use any of the methods as per your convenience. You can easily use them. So we have solved for the number of moles. Now in second part, we have to find number of molecules. As we know that 1 mole is equals to 6.022 into 10 power 23 molecules. Therefore 0.1 mole is equals to 0.5 into 6.022 into 10 power 23 molecules, that is 3.011 3.5 to the 10, 5 to the 10 and 1 11, 3.11 into 10 power 23 molecules. So this is the second part. Students, now suppose part C, where we have to find out number of atoms. It is not the atomic mass, it is the molecular mass, it is the mass of the molecule. So we will find out, that is, even if the question is directly asked to find out the number of atoms, then you must calculate the number of molecules first and then go for the number of atoms. Like in ammonia, you see 1 molecule of ammonia. Now you can see what are the number of atoms. There is 1 atom of nitrogen and 3 atom of hydrogen. So in all, 1 molecule of ammonia has 4 atoms, but we need only hydrogen. So we can write for hydrogen. So we can write 3 atoms of hydrogen. 1 molecule of ammonia contains only 3 atoms. So we have calculated earlier the total number of molecules. So what will be the number of atoms? Number of atoms of hydrogen is equals to 3 into 3.11 into 10 to the power 23. This number is from answer of B, where we have calculated the number of molecules, and as we know, one molecule of ammonia will have 3 atoms of hydrogen. So suppose if we have 10 molecules, then 10 into 3, 100 molecules, 100 into 3. Similarly, if this is the number, then you will write here 9.33 into 10 to the power 23 atoms. So this is the answer. So students, in this way you can find out the moles, the mass, the number of atoms, the number of molecules, and so on. Suppose in some question, take one more example. Suppose in some question, the number is given and mass has to be calculated. Like question is here, find the mass of 12.044 into 10 to the power 23 molecules of CO2. Now again we have taken the molecule, compound. So we should calculate its gram molecular mass, because we have to compare its mole. Find the mass of, we have to calculate mass. So we will go for the gram molecular mass. So we write here, that is gram molecular mass, gram molecular mass of CO2, 12 plus 16 into 2, hence 44 gram. Now number is given and we have to calculate the mass. So we know that 1 mole means Avogadro number is equals to gram molecular mass, means 6.022 into 10 to the power 23 molecules. Since there is a compound, so we will use the term molecule, not the atom. If it will be atomic mass, we will use atom. It 6.022 into 10 to the power 23 molecules of CO2 is equals to 44 gram. Therefore, 1 molecule will be 44 upon 6.022 into 10 to the power 23, and therefore 12.044 into 10 to the power 23 molecules will have 44 upon 6.022 into 10 to the power 23 into 12.044 into 10 to the power 23. Now this is cancelled and this will be cancelled with 2, hence it is 88 gram. So students, I have just solved the mole concept, its relation, with the help of some examples. I think it will be quite clear to you. Now go through every point, watch the video sincerely, and then go through your exercises. It will be quite clear to you. You will be able to solve all the questions. At the end, if there will be any problem, you can ask question by writing in comment section or contacting us directly on phone or WhatsApp number. Now finally, if you like our teaching, our video, then like, share and subscribe our channel. At the end, press the bell icon in order to get the latest videos. Thank you.